Okay, let's prove our first theorem together. And our theorem says that if we have three integers, and we know, call them A, B, and C, and we know the first one divides the second one and the first one divides the third one, then it must be that the first one divides the sum. And this kind of makes sense for what you know. Well, it doesn't kind of make sense. It makes sense. For example, 3 divides 6 and 3 divides 9, for example. So 3 should divide 6 plus 9, which is 15. 3 does divide 15. You can come up with your own examples as well. So let's go ahead and prove this. What we're going to do for this proof is we're going to go directly. So we're going to assume both of the things on the left, that is A divides B and A divides C. And then from that, we're going to arrive at the statement on the right. So let's start off by writing out what it means for A to divide B. If we go back to the definition, we'll know A divides B if and only if there is some integer. I'm going to call it D in this case. It doesn't matter what we call it. So there's some integer D such that A times D is B. So the only thing that happened in the first sentence is writing out the definition of divisibility. For our second sentence, we're going to write out the definition of divisibility with A divides C. So since A divides C, there must be some other integer, which I'm going to call E, such that C is AE. All right. So what we've done so far is we've just written out what both of the symbols in the hypothesis mean. Now we're going to try to arrive at the conclusion. For the conclusion, we're going to investigate B plus C. Why are we going to investigate B plus C? Well, we have expressions for B and C. So now it's time to investigate B plus C. We're just going to follow our nose. So B plus C on the one hand, well, B plus C, what is it equal to? Well, for our first sentence, B is AD. And for our second sentence up here, C is AE. So let's just plug those in. And what do we notice here? We notice that A is a common factor of both of them. Great, so we can factor out the A. So what have we learned here? If we read from the left to the right, B plus C is A times this quantity D plus C. But whenever you add two integers, you again get an integer. So D plus E is itself another integer. And so what we found is an integer called D plus E, which satisfies the following equation. When we multiply it with A, we get B plus C. That's exactly the definition of divisibility, but for the integer, we have a slightly more complicated expression for the second factor.